Hi, I'm John Everett with Zurn Industries. I'd like to take this opportunity today to talk to you about our compound check. The Zurn Wilkins compound check is used in all of our backflow preventers, the 300-400 series, in sizes 2.5 through 12 inch. Now, we get quite a bit of questions about why do you call it a compound check? So today, to help demonstrate this, I've asked our product manager here at Zurn Wilkins, John Mankins, to come in and help give you a rundown on how this really works.
Hello.
What John has is a compound bow, and we're going to use this to demonstrate why we call it the compound check. But a little bit of background on the bow. The reason they call it a compound bow is due to the cams and rollers that they put at the end of each one of the limbs. What these cams and rollers do, as John draws the string back, the roller will roll outward and it increases the length of the limb. What that serves to do is decrease the amount of force that it takes John to draw the string back. So I'll step on back and I'll let him demonstrate that. He'll go ahead and pull the drawstring back, and you'll see when he first starts off it's a very high load, but as he progresses through the pull, when he gets it back to his face, that's where the least amount of force is being placed on his arm. You can go ahead and relax that, John. Now, as he lets go of that string, those rollers in turn move back in towards the limbs, they shorten up, and that increases the amount of force that that string has when it finally lets the arrow sail. So based upon that principle, we've tried to incorporate the same things in our compound check. What we have in these check valves internally, there are two torsion springs that are buried inside, and they're connected to moment arms with rollers. Now, when this check is in a closed position, it's very much the same as John's compound bowl. We've got a very, very high load holding this check in a closed position. But as I push on the check and the check begins to stroke open, that load diminishes. It becomes very, very low. So that's the ideal action for a check valve in a backflow preventer. What you want is the check valve to have a very, very high load when it's in the closed position. That means it's going to develop a good differential, and that's going to serve to prevent backflow. But ideally, when the check valve is open, you want as little spring load as possible, because the spring load in a check valve is what serves to increase the head loss across the backflow preventer. So again, utilizing the same principle that John showed us with the compound bow, we incorporate those principles into the check. Now once again, I'll go ahead and I'll push on this check and open it up, and it's a little difficult to see, but we'll get a shot here close up. You have these rollers setting on ramps that are at two different angles. When the check valve's in the open position, that basically throws most of the spring load outward. Just enough spring load is left to make the check want to roll itself closed. But again, when it closes itself off, now we have a very high load closing the check, and once again, that yields a good differential. It helps to prevent backflow much more readily than if we had a low differential. So again, just pointing out the features of this check, why we call it a compound check. It was really based upon the principle that John just showed us with the compound bow. I hope this clarified why we call it the compound check, and I certainly hope that you enjoyed this video. If you liked our video, please subscribe to our YouTube channel. For more product information or to speak to a customer care representative, please visit our website at zurn.com.